Hi everyone. In this video, we are going to use trigonometry to find unknown angles in a right-angled triangle. Last time, we calculated side lengths. This time, we're going to do something different. We're going to know the side lengths, and we're going to use those to figure out the angle. So, you may have seen, for instance, that sine of 30 is 0.5 or a half. When I say this, I am saying sine of an angle gives me a number. What I would like to do today is say, if I know the number, can I work out the angle? And the answer is yes, we can do that if we have a calculator. So if I know this, another way of writing this today will be to say the inverse sine of 0.5 is 30 degrees, although your calculator will just say 30. And this is going to be inverse or opposite or reverse sine. And I'm going to put in a number and get an angle as my answer. So let me just show this to you to give you an idea of what this looks like on the calculator. So I'll just clear this. So I claim that sine of 30 is a half, or 0.5, there you go. And let's say I wanted to go backwards. What I could do is say if I knew that sine gave me 0.5, what would be the angle that got me that? To do that, I need to use the inverse sine, which is written as sine minus 1. And notice it gets me back to 30. All right, let's do something a bit different. Let's imagine I gave you cosine of 28, and I asked you to calculate that. And I get 0.8829. Now, if I find the inverse cosine, or cos minus 1, and type in this number, let's see what we get. We get back to 28. So when you use the minus 1, you're going from the number back to the angle. And that's what today's video is all about. We want to use the inverse trig functions, inverse sine, inverse cos, and inverse tan. And that's going to give us an angle as our answer. I know it's a bit abstract, so let's make this concrete with some examples. Well, the examples aren't yet, they're on the next slide, so I just want to get you used to working with the notation. So you'll notice here I'm saying, tell me what the angle theta is in degrees. So I'll write that as well in degrees. And you'll notice I haven't actually drawn a triangle here. We don't need to. If you want to know why it doesn't matter that we don't have a triangle, ask your teacher in class, because that deserves a longer explanation than what is possible in a video like this. So here we were saying sine of an angle gives me a number. Hence, if I take the inverse sine of the number, I get back to the angle. Now, it's more common to write what we're trying to find on the left-hand side. So I'm going to do that as well. I'm going to write theta equals the inverse sine of 0.8. And now we go to the calculator, go to trig, and look for sine minus 1. If you're using a scientific calculator, you'll probably need to use the shift button. So 0.8, and this gives me 53.130 degrees. And that's approximately 53.1 to 1 decimal place, because the second decimal place, the number 3, is less than 5. Okay, next one. Suppose I told you that cos theta is 0.2. We'll just make the decimal point a bit clearer. To get rid of the cos, I need to take the inverse cosine on both sides. So theta is going to be inverse cosine of the number that we were given. So remember, cosine of an angle gives us a number. So the inverse cosine of the number gives us the angle. If we go back to the calculator, the inverse cosine of 0.2, it's going to give us some angle, in this case 78.463. And if I round this up to 1 decimal place, I get 78.5, because the second decimal place, 6, is larger than 5. Lastly, if I know that tan of the angle theta is the number 3.2, then the inverse tan of the number gets me back to the angle. So if I go back to my trig function, which is an inverse tan minus 1, 3.2, I get 72.645975. And if I round this to 1 decimal place, I get 72.6, because the next digit is less than 5. Okay. Now let's do this with some pictures. All right, so hopefully this is a bit more concrete now. We want to find theta. So the question hasn't changed. We want to find the angle theta to 1 decimal place. Our first step, naturally, is to label the sides of the triangle. So here we've got the opposite and the hypotenuse. So sine theta equals 20 divided by 32. And I know this is a fraction, not a decimal, but they're both numbers. So I can do the same thing. Theta is the inverse sine of whatever number it was. And even though that number is now written as a fraction, I can still do that with inverse sine. So this is what I'm going to type into my calculator. Inverse sine of the fraction 20 divided by 32. This gives me 38.68. And if I round this to 1 decimal place, I get 38.7. Next example. Here, we've been given O and A. So, tan theta gives us the opposite over the adjacent. Tan theta gives me 34 over 25. Therefore, to get the angle theta by itself, I need to take the inverse tan of the number 34 on 25. And I will type this into the calculator. Inverse tan of 34 over 25. And that gives me 53.67. And if I round this to one decimal place, I get 53.7 degrees. And that's it. There's not much algebra this time, except for moving from the trig ratio to the inverse trig ratio. So if you can do this page, you can also do this page. And I think it's worth just adding one more comment before we wrap up for today, with a warning. And that is, when you studied indices, you wrote x to the power of minus 1 as 1 divided by x. However, if we say inverse tan of theta, it is not the same as 1 over tan theta. So just bear that in mind. In fact, tan minus 1 means inverse tangent. And really, I shouldn't write theta here because we don't put angles into the inverse tan. We normally write a number. So I'm going to call that number x. Okay? So just be aware, tan minus 1 does not mean 1 divided by tan. As long as you remember that, you're going to be fine. All right. See you in the next video.